Pre-UTME physics quiz. I'm going to be starting with question number 1. We have the values of x, y, and z respectively in the expression for the universal gravitational constant G are as follows. So our universal gravitational force is gotten from F equals Gm1 m2 divided by r squared. So what you need to do is to make G the subject of formula A. So that means that when you cross multiply, you're going to have F multiplied by r squared. So G is going to be F multiplied by r squared. And since you have m1 and m2 with G, so you're going to have divided by m1 over m2 here. And you don't need to be breaking this down too much. All you have to do is to look for the SI unit of force. Force is in Newton, and Newton is the same thing as kilogram meters per second squared. R is in meters, so that is meter squared. And these two guys are in kilogram, so that's kilogram squared. So if you get rid of these, one of these kilogram will cancel out, or you can use indices. Kilogram raised to power 1 over kilogram raised to power 2, that's kilogram raised to power 1 minus 2, and that is going to be kilogram raised to power negative 1. Then this is meter here, and this is another meter here, so that we have meter raised to power 3, and then we still have second raised to power negative 2. Once you have been able to get these SI units, you should know that kilogram, the dimension of kilogram is capital M, dimension of meter is capital L, and dimension of seconds is capital T. So therefore, this will be M raised to negative 1, L raised to power 3, then T raised to power negative 2. So that implies that the correct combination here will be negative 1, 3, and negative 2. So the correct answer to this question is option B. Now let's go to question 2 now. In question 2, we have which of the following quantities has the same dimension ml raised to power 2, t raised to power negative 3. So quickly, some dimensions that you should be familiar with actually are that of power, acceleration, density, and work. It cannot be acceleration because acceleration is Lt raised to power negative 2. Now for density is mass over volume, and that is m divided by L raised to power, so that will be ml raised to power negative 3. That implies that we're left with work and we're left with power. Now for power is simply work done divided by time, and work done is energy. Energy itself is the same thing as force multiplied by distance. So, and like I've said here, force is this. So force times distance, that is what will give us work done. And work done is now going to be kilogram. Since this one has 1 meter, and D will also be a meter as well. So that will be kilogram meter squared per second squared. But when you divide this by time, you are going to get power. So that is multiplied by S raised to power negative 1. And so that will be kilogram meter squared S raised to power negative 3. So when you do the same comparison that I did earlier, so that will be a dimension of m L squared, then T to the negative 3. By the way, like I said, you should be familiar with some dimension already. Instead of you calculating them or maybe solving them like this, you should be familiar with the way they work. So this dimension is the same thing as that of power. And then it says, which of the following are vector quantities? Which of the following are vector quantities? Work is not a vector quantity. Displacement is a vector quantity. Acceleration is a vector quantity. Electric field intensity is a vector quantity. And also, magnetic induction is also a vector quantity. So that implies that we have combination 2, 3, 4, and 5. So the correct option here is C. So therefore, the combination, we have A, we have C. The combination of the correct answer will be A, C. Number 3, it says we have a car that starts with a velocity of 2 meters per second. So that means that the initial velocity of that car is 2 meters per second and moves with a uniform acceleration of 6 meters per second squared for an interval of A equals 6. An interval of, so total time is 2 seconds. But this motion is centered at 5 seconds. Whenever you see a question that says centered at something, and then the duration is 2 seconds, so that implies that you're going to start from 5. You're going to divide your 2. You're going to divide it into 2. So, and that is 1. So you have plus 1. So that means that 6 to the right and you have plus 1 to the left. So that implies that the motion happened from time 4 seconds to 6 seconds. Let's say the total duration of the time was, let's say, something like 5 seconds instead. You divide 5 seconds by 2, that's 2.5. If it is still centered at 5, so we're going to have 5, 2.5 to the right, that would be 7.5, and 2.5 to the left, that would be 3.5. No, sorry, that would be 2.5 as well. So the time duration will be from 2.5 seconds to 7.5 seconds. That is what it means whenever it says something is centered at a particular time. You just divide the duration and you take the half to the right and you take the half to the left. So for this particular question now, we are to calculate the distance covered in that 2 seconds. So we're going to be using distance S equals U change in T plus half area times change in T squared. So this is what we're going to be using. We're using this because we are considering the interval between 2 time period, and that's going to be the U is 2, then the change in time, that is going to be since it's from 4 to 6, that's going to be 6 minus 4 plus 1 over 2. The acceleration is 6, then the change in time squared, that is going to be 6 squared minus 4 squared. So this is going to be 6 minus 4 is 2. 2 times 2 is going to be 4. Then this is going to be 3. So that will be plus 3. 6 squared minus 4 squared, that is 36 minus 16. Yeah, 36 minus 16, that will be 20. So that will be 3 times 20 is 60. 60 plus 4. So that's going to be 64 meters. So the distance covered is going to be 64 meters. Okay, question number 4. A metal ball is thrown vertically upward from the top of a tower with an initial velocity of 20 meters per second. If the ball took a total of 6 seconds to reach the ground level, determine the height of the tower. Now, if the ball, so you have a tower here, and they said it was thrown vertically upward with an initial velocity. So they threw upward like this. Of course, this is how the motion will go, and it was thrown with an initial velocity of 20. If the ball took a total of 6 seconds to reach the ground level, determine the height of the tower. Now, there are so many ways that you can do this. One of the ways that you can do this is that you know the initial velocity. You can use the principle of conservation of energy, or you can as well analyze the motion. How much time will it take to reach up first? You can calculate how much time it should take to reach maximum height. Now, one thing that happens at maximum height is that the final velocity is going to be 0. And if the final velocity is 0, so you can use this motion going up, you can use H equals UT minus half GT squared. I mean, for the going up version, so that implies that the height that is going to travel through, we don't know the height that is going to travel to when it's going up, so that implies that this equation is not going to be useful for us. So we can use V equals U minus GT. Now, using V equals to U minus GT, we know that V is going to be equals to 0. U is 20 minus 10 times T. When you do this very well, your T is going to be 2 seconds. That implies that the total time it took from here to the maximum height is 2 seconds, which implies that the remaining time was 4 seconds that it used in coming down. And one thing about motions like this is that, as you see, as this 20 meters per second is going up, and I said when it reached the maximum height, it became 0. As it is coming down, it begins to gain that speed back, such that when it gets to this level again, it has the same velocity. The other time it was going up, this time around it is coming down. So at this point, you still have 20 meters per second. So which implies that you can also get the total time it took to fall from this 0 velocity to 20 meters per second again. In fact, you don't need to calculate anything, because in projectile, the time taken to move from one level to a particular height is the same time it will take for the motion to drop from that height to that level again. So that is the time taken to reach maximum height, which is the time of half of time of flight. Time of flight will happen from this region here to this region here. So if you got 2 seconds for this one, that means that this time here is also 2 seconds. And out of 6 seconds, 4 seconds is gone. And that implies that the remaining time left from here to here is going to be 2 seconds as well. And this height that it would have fallen through at this point, it will correspond exactly to the height of the tower. So now we can use this particular equation that I highlighted right here. Although this one is for going up, for going down is going to be positive. It's going to be plus. So now, what is our initial velocity? So your initial velocity is going to be right from this point, which is 20. So h is going to be 20 multiplied by, if established that the time it will take to fall that will be 2. So plus 1 over 2 times 10 times 2 squared. So this is going to be 20 times 2 is 40. This is going to be 5. 2 squared is 4. 4 times 5 is 20. So we're going to have 60 meters. So the correct answer to this guy is going to be 60 meters. Number 5 says a man whose mass is 70 kilograms stands on a spring weighing machine inside an elevator. What is the reading of the weighing machine when the elevator starts to ascend with an acceleration of 3 meters per second squared? Permit me to solve that on this page. Now, whenever you see a question like this, it's very, very easy, and you just have to assume that, okay, this is the man in an elevator. First of all, the weight of the man, the weight is always acting downward. So, and the weight is mass times acceleration due to gravity. So this person has a mass of 70 kilograms. Therefore, their weight is going to be 700 newtons. So it is acting downward. Now, it says the spring, so they stand on a weighing machine. What actually the weighing machine read is what we call reaction. So the reaction is going to be upward. The weighing machine, it shows reaction, not the weight itself. It is the reaction of the weight that you are pressing on the weighing machine that is going to show you back as a reading. So weight acts downward, reaction acts upward. These are going to be the two forces in this system, and we need to find the net force in this system as well. To find the net force, we need to consider where is this person moving towards. The person is ascending, accelerating at the rate of 3 meters per second squared. That implies that the upward force will be the positive force. In this case, we have R minus 700. So R minus 700 equals, whenever you have found the net force equals always equal to mass times acceleration. So what's the mass of the person? 70. And what's the acceleration? The acceleration is 3. So that implies that we can now solve for R now, which is what the scale we actually read. R will be 70 times 3, that's what? 210. When you take negative 700 to the other side, you have plus 700, and that will be 910 newtons. So the scale is going to read 910 newton like that. Now, if it was going down, that would have been 700 minus R equals 70 times 3. Because going down, that means that the downward force will be the positive force. Let's go to question number 6. A 10 kg mass is dragged along a horizontal table by a force of 60 newton inclined. So we have this guy, 60 degrees, 60 newtons, and this is 10 kg. So that means that the weight of the body is going to be 100 newton acting downward, 30 degrees to the horizontal. So we have 30 degrees to the horizontal. The coefficient of dynamic friction between the mass and the table is 0.15. Calculate the acceleration of the mass. So this is also a case of net force. Now you should notice that on this horizontal, there are two major forces that will be acting there. Of course, the horizontal component of 60 and frictional force, which is always acting against the direction of motion. And if you resolve this to the horizontal, you're going to have 60 cos 30 degrees minus the frictional force. However, frictional force itself depends on normal reaction. It depends on normal reaction. So meaning that we have to find our normal reaction in this question. And just like I've explained earlier, when you're pressing down on something, it's going to be a normal reaction. So the normal reaction is going up here now. We need to solve our normal reaction in this question. So to solve for normal reaction, let's keep this one. 60 cos theta minus FR will be equals to MA. The M is 10, so 10 times A, we're looking for the acceleration. So we're going to keep this for now. Yeah, I'm just going to keep it right here. Now, so I just did for the horizontal, and that's why I kept it like that. Let us do for the vertical. The vertical, there are three forces acting there. We have the normal reaction, we have the weight acting downward, and we will have the vertical component of this guy. As you can see, both of them, R and the 60 newton, they are acting upward. So we make them positive. So we have R plus the vertical component of 60 is going to be 60 sine 30 degrees. then the weight is acting downward, that will be minus 100. And we're supposed to equate this one to MA as well, but because there is no motion along this path, everything here is going to be 0. So R is going to be 100 minus 60 sine 30. Sine 30 is 0.5. So 0.5 times 60 is going to be 30. So this is going to be 70 like that. So now that we've gotten R, we can easily get our frictional force. Frictional force is mu R, like I've stated here. What is mu? Mu is 0.15, and 0.15 times 70. So 0.15, let me press my calculator for that. 0.15 times 70, that's going to be 10.5. So this frictional force is 10.5. So if I go back to this now, let me bring this down here. If I go back to this now, so that will be 60 cos 30 minus frictional force equals 10A. I just need to divide all these answer by 10. Now, 60 cos 30 is root 3 over 2. So take note of that. 60 cos 30 is, or you can do 0.8660. 0.8660 is cos 30 for the sake of Jamb. So having 60 cos 30, which is 60 cos 30, then you subtract the frictional force from it. The frictional force is 10.5. So that implies that we'll have everything as 41.46 equals 10A. So when you divide this by 10, you get 4.14, approximately 4.14 meters per second squared. That's 4.15 rather. So that's approximately 4.15 meters per second squared. That will be the acceleration of the system. It says a body of mass 8 kg is connected to a body of mass 5 kg with an inextensible string over a frictionless pulley. The 8 kg mass, okay, let's quickly drop that. We have this. So this is the case of the half Atwood machine. So you have a body resting here. You have another body resting here. So it says a body of mass 8 kilograms. So if the body has mass 8 kilogram and connected to a body of mass 5 kilogram with an inextensible string over a frictionless pulley, the 8 kg mass hangs vertically. So that means that this is going to be the 8 kg mass and this is going to be the 5 kg mass. Rest on a horizontal table, calculate the force of friction between the 5 kg mass and the table if the 8 kg mass accelerates downwards at 4.5 meters per second squared. Now, this is what is going to happen. Whenever you see a half Atwood machine like this, it is definitely who will be causing the motion is going to be the 8 kg, the hanging mass, because it will want to move downward. So let's assume that it is moving downward. As it is acting downward, then automatically tension will be generated upward in this string. And once the tension is generated, the same tension we want to pull this 5 kg to the right. And since the motion now is going to be to the right, that means that the friction is going to be to the left. So in this situation, we have to analyze these two situations. Now, the first situation is going down. What is acting downward is the weight of this guy, which is 80 newtons. What is acting upward is tension. In this place, tension is acting to the right and friction is acting to the left. The acceleration of the system is going to be the same. So both of them are going to have the same acceleration. So for the downward part, you have 80 minus tension equals 8A. That is, you should be used to this by now. Anytime we find our net force, we always equate it to mass times acceleration. Then for the second case, you have tension minus frictional force. This frictional force is exactly what we're looking for, equals 5 times A. In this case, the mass accelerating is the mass 5 kilogram. Now, we know our A already. A is 4.5. So quickly, let's get 8 times 4.5. 8 times 4.5, that is 36. So this is going to be 36. And 5 times 4.5, 5 times 4.5, that is going to be 22.5. So with this now, I can easily solve for my frictional force here. As you can see, I can add the two equations and solve simultaneously. If I add, that will be 80 minus tension plus tension is 0. So then this will be 80 minus FR equals 36 plus 22.5. That is going to be 58 58.5. So therefore, frictional force is going to be 80 minus 58.5. 80 minus 58.5. So that should be 80 minus 58.5. Yeah, so that's 21.5. So the correct answer there is 21.50 newtons. The next question says two bodies A and B of masses 10 kg and 4 kg move towards each other with velocities of 6 meters per second and 3 meters per second respectively and collide. If the collision is perfectly inelastic, calculate the loss in kinetic energy. So that's going to be very, very easy. We need to calculate their common velocity first. When we know their common velocity, then we can know the loss in kinetic energy. But while we're doing that, we can easily just calculate their the total initial energy that they both have. That will be 1 over 2 times 10 times c squared plus 1 over 2 times 4 times 3 squared, because kinetic energy is half mv squared. So this will be 5 times 36. 5 times 36, that's 180, plus this will be 2 times 6. Oh, sorry, 2 times 9, that will be 18. So total energy here is 198 joules. That's the initial. Now let's find their common velocity. To say it is perfectly inelastic, that means that they started like this. One is moving like this, one is moving like this. When they collided, then they got stuck together because both of them are moving towards each other. So now when they are moving towards each other, that means that one will have a positive momentum and the other will have a negative momentum. The one with positive will always be the one with the greater momentum. So let's see, 10 kg 6 meters, so the momentum of that one is going to be 60. 4 kg 3 meters per second, so that's going to be 4 times 3, that's going to be 12. So we have what? Negative 12 like that, because they are moving in opposite direction. So their total momentum before collision is m1 v1 minus what? m2 v2, because they are moving in opposite direction. So that's why there's a negative sign there. Then finally you have their common velocity. When they are stuck together, their total mass is now going to be 14, then multiplied by v. So that implies that 60 minus 12, that is 48. So 48, so v is going to be 48 divided by 14. So 48 divided by 14, that is 3.43. So when we have 3.43 now, we can now calculate the kinetic energy after collision. So their kinetic energy after collision, that will be half times. We have to add the two of them first. That's 10 plus 4 is 14, because they have those kinetic energy in common. Now, their velocity is 3.43. So 3.43 squared. So that is 11.76. So multiply by 7. So that is going to be 82. So when you do all this, I'm trying to be as fast as possible because this is supposed to be a mock style, but I'm also trying to be as detailed as possible as well. 82.29. So you subtract 82.29 from 198, which was the initial energy that they were moving with. And when you do that very well, you get 115, approximately 115.65. Approximately 115.65 joules. That's the correct answer to that. Next one says a plane inclined at angle 30 degrees to the horizontal has an efficiency of 60%. The force parallel to the plane required to push a load of 120 Newton uniformly up the plane is going to be what? Now, we have been given the angle of inclination, we have been given the efficiency. So we're looking for the force that will be enough to pull this guy up. Now, one thing you know about efficiency is that efficiency is going to be mechanical advantage over VR times 100%. Or you can use work output over work input times 100%. Now, if you want to use work output over work input as 100%, in this place, they said the plane is inclined at angle 30 degrees to the horizontal. So we have this. So you can easily get the efficiency as 60%. Okay, it has been given already. The force parallel to the plane required to push. So let me draw the plane. So let's say this is the plane. Inclined at 30 degrees. So this is the box. Now you're looking for the force that will push this load. This load itself is 120 newtons. So from what you know that um, if you get your mechanical advantage, then you can get every other thing. Velocity ratio for an inclined plane. Take note, the angle is to the horizontal. Very good. As the angle is to the horizontal, your velocity ratio is going to be 1 over sine theta. And that will be 1 over sine 30. Sine 30 is 0.5. So that means that our velocity ratio is 2. So the first formula is better. So when we have that, so we just have that efficiency, which is 60, equals MA over 2. Velocity ratio is 2 times 100. So there we have 2 times 60 is what? 120. 120 divided by 100, that's going to be 1.2. So the mechanical advantage is 1.2. If the mechanical advantage is 1.2, mechanical advantage is also the same thing as load over effort. And we've been given the load. The load is 120. So therefore, our effort is going to be 120 divided by 1.2, which is going to be 100 newtons. So the force is going to be 100 newtons, like that. Number 10 says a wheel and axle is used to raise a load of 500 newton by an effort of 250 newtons. So what are we looking for? Efficiency. So we can quickly get our mechanical advantage like that. That is 500 over 250, load over effort. So mechanical advantage is 2. They have given us the radii of the wheel and axle. So the velocity ratio of a wheel and axle is the big radius over the small radius. The big radius is 0.4. The small radius is 0.08. So 0.4 divided by 0.08, that is going to be 5. So therefore, our efficiency is going to be MA over VR, that's 2 over 5 times 100%. So 5 here is 20, so that will be 40%. So the efficiency is 40%. So I'm going to start about question number 10 for this video. In the next video, I'm going to be continuing with question 11 to 20, and then we'll do it like that until we finish the solution.